So first thing, random variable. Okay, random variable. So what is a random variable? What is a random variable? So random variable is a function. Okay, it is a function that maps the outcomes of a sample space to real numbers. Okay, so whatever are the outcomes of a random experiment that we do, those outcomes are mapped to real numbers. Why is it important? Because those abstract concepts of the of the random experiment that we are doing, that will be converted to a real number, and that real numbers can now be used for mathematical analysis and manipulation, and then a, a generic thing from the real world will become a mathematical problem. We can model a real world problem into a mathematical problem, and the random variable is the tool, is a function which converts that outcomes to a real number. For example, I'll give you an example. For example, so let me write the definition for you. Okay, it is a function that maps the outcomes of a random experiment, or what that is called sample space that we saw in the last video, random experiment, to real numbers. And once it is converted to a real number, now we can do all the mathematical operations on that. And it's represented. How is it represented? It's represented by, so we say that x maps this is our random variable to a real number. So this is our real number. So this is our random variable. This is our sample space, omega, of all the possible outcomes of the random experiment. And r is a real number. Okay, so this is what is in nutshell a random variable. Let me give you an example to make you understand better. For example, we'll go with the simple example of tossing a coin. Okay, so for example, we toss a coin 2 times. Okay, so what are the possible outcomes? What will be our omega? Either we get head tail, tail head, or both tails. These are sample space. Now we have to map this experiment into real numbers. So for example, we want to count the number of heads. So we want to count the number of heads in 2 coin tosses. So what are the possible number of heads? It can be 0 heads, 1 head, or 2 heads. 0 head when we get both tails in both the experiment. 1 head in these two, either I get a head in the first toss or in the second toss, and 2 heads means in both the tosses I get heads. So these are the possible outcomes, and I want to map this to real numbers. So now this, you can see now that this random experiment of, or a real world example of tossing a coin, has been converted from a sample space, okay, to real numbers. And how we'll do that? So this is expectation values. So let's see how, using the random variable, how can we convert that. For example, so now what is the count of getting 0 heads? Okay, what is the count for getting 0 heads? So 0 head would be a sample outcome of tail, so this will be 1. Now again, what is the random variable mapping of 1 head? That would be head, tail, and tail head. This will be 2, and getting 2 heads is only 1. So this is our mapping. This is our, here x is our random variable which is mapping an outcome of a random experiment, that is number of heads, to real numbers. These are the real numbers. Number of 0 heads, 1. Number of 1 head, 2. Number of 2 heads, 1. I hope this is clear. and similar output will be received for number of tails also, right? As we dive deeper, I'll give you more examples. For example, we mm, map in Bernoulli distribution, right? We map a success and failure to their corresponding probabilities given by p and 1 minus p. Similarly, if you discuss about Gaussian distribution, there we map, let's say for example, height of people. Okay, we might map a given. We are given a set of height of people, and that we map to mathematical distribution or probability distribution using its mu and sigma. Mu is the mean, sigma is the standard deviation. Okay, so these are some examples. So when I dive deeper into Bernoulli and Gaussian distribution later in the other video, then you will get more understanding of it. But this is a high level idea that how we are mapping a real world example into the outcomes of the real world example into real numbers, so that we can do mathematical analysis on top of that. I hope that is clear. So this is your random variable. Again, depending upon the outcome or the kind of data that we are dealing with, random variables can be of two types: discrete and continuous. What is discrete? We have seen discrete in the past also. So if we say what is discrete, so I will denote this random variable using RV so that it's easier for me. Okay, RV. So first one is discrete. So what is a discrete random variable? We know what is discrete. Discrete is anything. So a random variable, okay, that can take a finite or countably infinite number of values. Okay, so which can take finite or countably. The point is counting. It's possible to count countably infinite values. Okay, that is your discrete. That is your discrete. So the main point here is that the values are often obtained by counting. So we obtain the values by counting. Obtain values by counting. Okay, and and it cannot take a number in between. Okay, so it cannot take a number, any number. It will only take countable whole numbers. It cannot take any number in the in between. Any value in between two consecutive values. Two consecutive values, because it is discrete. Okay, that's what your discrete random variable means. For example, let's see the earlier example that we have seen. For example, we toss a coin twice, toss a coin 2 times, and count number of heads. We have seen this earlier. Either we can get 1 head, 2 head, or one means either we can, when we see, either we can get 0 heads, 1 head, or 2 head. So these are the counts, and these are the corresponding numbers to that. So this random variable is mapping 0 count to 1, 1 count to 2, and 2 count to 1. Okay, so we are getting these real numbers. So is it possible to get 1.5 heads? No, right? So either we can get 1 head or 2 heads. We cannot get 1.5 head. So this is what this last statement means. Cannot take any value in between two consecutive values in discrete. Okay, so I'll write it. Cannot get 1.5 heads here. Okay, I hope this is clear. Now let's move to the second one. The second one is continuous. So the continuous random variable, what is it? So we have seen in the past what is a continuous random variable. So continuous random variable can take any value within a specified range. Okay, it can take any, generally it's in the form of a curve. Okay, it can take any value, so it will take infinite number of values between a given range. If you have a number line, so it can take infinite numbers values within a range. So generally, whenever you have a continuous values of data, for example, when you have like we saw the example, right, heights of people, okay, so it can take continuous values, okay. So that's what is a continuous random variable. Let me write it down for you. Can take any value, sorry, within a specified range. So this is a, and we have seen earlier that there can be infinite such numbers. This will be kind of revision for your discrete and continuous events that we have seen earlier. So the terms continue, this discrete and continuous, this you will see across probability all the time. So this is very important to understand. So these terms will keep on coming. So there can be infinite possibilities. For example, okay, so I'll give you an example. For example, we are let's map height of people, okay, a person's height, and say it is anywhere in the range between, say, for example, 100 centimeter to 200 centimeter, and we know that this will follow a Gaussian. I'll discuss about Gaussian later. There also I'll give you the example. It will follow something like this. Depending upon the country, there will be some average height. For example, if it's India, maybe I may be wrong, but say for example the average height is your mu or mean height is this, okay. So most of the people will have this height here, okay, and there's a possibility of finding any height. So we can have heights like, for example, the height can be anything. It can be like 165.1 centimeter or 167.22 centimeter or 189.356 centimeter, anything. It can have any values. It can have infinite number of values in any range. That's what this, because this is continuous, okay. So that's what it means, a continuous random variable. So it will capture the meaning of whatever the meaning of this curve, and it will map it to a real number, okay, using this mu, and then this is the spread, standard deviation, okay. So this is the mapping. So I hope discrete random variable and continuous random variable is clear.